Hi everybody, welcome back. Tomorrow is the day of our math test. We are gonna have tests about the quadratic models, exponential models, and choosing a regression model. Yep, I feel like these are gonna be on the test. But anyways, let's first talk about the quadratic models. For the quadratic model, they represent the quantities that are quadratic, which do not have a constant rate of change. In a table of values, the second differences are equal, unlike the linear model that we learned from the past. A graph is a curve called a parabola. The equation is a degree of 2 and return in the form of y equal to ax squared plus bx plus c, where a doesn't equal to 0. For the first example, like this, we're going to take the h and the p. The h is 0, 1, 2, 3. But for the p is 250, 238, 202, and 142. So for the 250 minus 238 is going to be 12. The 238 minus 202 is 36. And then for the 202 minus 142 is 40. And then when the 36 minus 12 24, and then 60 minus 36 is 24. It's quadratic. For the B, it's still the same for the R, but for the quadratic is 48 minus 32 is 16, 72 minus 40 is 24, and then 108 minus 72 is 36, and then you're going to 24 minus 16 is going to be 8, and then 36 minus 24 is 12, and then 12 minus 8 is 4, and then it's not a quadratic because the second has to be equal. Second difference. But this one, the third one is, for C it's a quadratic. You can tell because it's a graph with parabola. I'm not gonna talk about it too detailed because I have a tongue pain. Fitting in the quadratic model to data, we can use quadratic regression to model data that appear lie along a parabolic curve and produce a quadratic curve, or best fit. So let's go into the second example. The distance is always 5, no matter what number they have. And for the height, is 75 minus 43 is 32, and then 97 minus 75 is 22, and then 108 minus 97 is 11, 109 minus 108 is 1, and then 109 minus 100, I was 100 minus 109 is negative 9, let me see if it's quadratic or not. 10. It's not a quadratic downward. No, it is actually. I'm sorry, guys. Determine the equation of the regression of parabola. Full is y equals to negative 0.206 x squared plus 9.4993 plus 0.7. The maximum of the regression curve is a 22.5110. So the equation is going to be y equals to negative 264 times 35 squared plus 9.4993 times 35 plus 0.7 is 80 meters height. So let's jump into the exponential models. I'm sorry for the bad pronunciation because of the tongue pain. I'm sorry, guys. Anyways, it's exponential models represent quantities that change a constant growth rate. In the table of values, the ratios of the y factors are equal. The graph resembles an exponential curve. The equation is written in the form y equals to a times b power x, where a is the initial value and b is the growth or decay factor. Notice that the exponent is the variable. The growth or decay factor. So in the exponential equation, if b is bigger than 1, the relation is exponential growth. Growth factor is 1 plus growth rate or stuff. If 0 smaller than b smaller than 1, the relation is exponential decay. A factor is 1 minus decay rate or stuff. Let me see which one is the exponential. Well, b is the exponential because 64 divided by 51.2 is 1.25. 80 minus 64 is 1.25. Since they are exponential or stuff. So to compare the initial value and the growth rate, growth decay factor. Sorry, yes, it's growth or decay factor. I pronounced it wrong because I'm not feeling well. Colony A is decay, as because of 102 power of t or stuff. Colony B is the growth because peak of 100 times 3 power of t. So the equation has a starting point move up to 200 stuff. The shape of the curve stays the same because the b doesn't change. We can use exponential regression to model data that appears to lie along an exponential curve to produce a curve of the past speed or stuff. So the third example, Excel was used, for the y equal to a times b in power of x or stuff because y equals to 0.5252 times 1.027 power of x. So h is 0.5252, which is the population, 1.027 years. Estimate the population. The population of British Columbia in 1985 is grown by 0.5252 times 1.027 in the power of 64 is 2.9 million. Let me see. Get with that. So, selecting a regression model. So until now we told which regression model is to use the model data, practical application, So let me go into the first example right away. But I want to say, we have to examine the first and second differences in ratios. Create a scatter plot of the data. Stuff. So for this one, times are 0, 2, 4, 6, 8, 10. The voltage at 9.0, 7.0, 5.2, 3.9, 3.0, 2.3. First difference are 7 minus 9 equals to negative 2. 5.2 minus 7 is negative 1.8. 3.9 minus 5.2 equals to negative 1.3. 3.0 minus 3.9 equals to negative 0.9. 2.3 minus 3.0 is negative 0.7. It's not linear. Second difference is negative 1.8 minus the negative 2 is 0.2. Negative 3 minus the negative 1.8, which is 0.5. And then negative 0.9 minus the negative 1.3 is a positive 0.4. With the last one, it's going to be negative 0.7 minus the negative 0.9, so 0.2. It's not a quadratic. So the ratio is almost constant because 7 divided by 9 so 0.77. 5.2 minus 7 equals to 0.74. 3.9 divided by 5.2 is 0.75. 3 divided by 8.9 equals to 0.76. Like that. The conclusion that the best regression model to fit this data is the exponential model because the ratios were almost constant. For this one, draw a scatter plot of the data that's 0, 3, 30. which I did. And 25 is 22.3, which is good. The 50 is 16.1. So 755 is 11.2, which is almost be there. 100 is 7. I did it. So as we use Excel, we choose the quadratic because it's closest to 1. So the model that best represent is a quadratic model because the value of R square is closest to 1, you know. Thank you guys for watching this video until the end. Last thing, wish everybody good luck in the math test for tomorrow. I want to say we have to do a good job in the math test to prove anybody can target math. See you later.